Welcome back, grade 11s. Okay, so first box, you should know this off by heart by now. Standard form of a quadratic equation is y, or 0, equals ax squared plus bx plus c. Okay, keep in mind here, last time we wrote it, we wrote the 0 on the right hand side. Does it matter? No, it does not. Okay, so here we wrote it on the left, that's okay. Let's put a little note in that this here, that's y, which is also the same thing as f of x, right? Sometimes we see the y there, sometimes we see an f of x, sometimes we see a 0. Good. What else do you know about this equation? You could probably tell me that A determines the concavity, whether it opens up or down, and you could probably tell me that this C tells you the y-intercept of the parabola. Today we're going to talk about how to use a quadratic function in factored form. So again, first box on your left, standard form, box on the right, factored form. Factored form states that y, or sometimes we write a 0, is equal to a. It's the same a as the previous question. It tells you the concavity, x minus r times x minus s. So it looks like a list of factors, doesn't it? You remember all the time we spent on reviewing factoring? Yes, these are the factors. So if I would multiply a times the first binomial times the second binomial, I would get the equation in standard form, all multiplied together. Okay? Factors, again, are a list of numbers and variables multiplied to get your original equation. So, let's write a few things about this. A, again, is the concavity. That's the up or the down. If it's positive, the parabola opens up. So sometimes we write this. That's if A is positive. Or this opening down if A is negative. Okay, the x-intercepts, I'll write the word out so we know what it is, are R and S. Okay, so right away from looking at the factors, you can see the x-intercepts. You can see where it crosses the x-axis just from these factors, from the r there and from the s. Notice that the x-intercepts are not the negative of the factors. Okay, they're just the r, so this has to be a subtract sign in the equation, and then the r and the s are the x-intercepts. It also happens that if you take the a, multiply it by the r, multiply it by the s, it equals c from this other equation. Okay, do you remember what c stood for? Let's write it in here. This is the y-intercept. Okay, so when I'm looking in the factored form, if I take a times r times s, it gives me c, the y-intercept. Another little handy formula from this is the axis of symmetry. Remember that runs straight down the middle of the parabola is going to happen at the equation x equals r plus s. Those are the two spots where it crosses the x-axis divided by 2, which does make sense. Okay, at 2 place, we know the very center of the parabola happens right in the middle of these two spots. So if we add them up and divide by 2, we get their average, or we get that middle spot. But all those equations are going to come in handy as we talk about the quadratic function in factored form. Okay, if you scroll down here and just look at your first page, this is a question that is answered in your textbook. Excuse me, I kind of wrote over this here, but it says this happens at page 384. You can go ahead and fill it in your own time if you want the answer written in your notes. Otherwise, you can look in your textbook. Let's skip over to this example number 1. It's asking us here to sketch a graph of that quadratic function. And we know already I could put that into Desmos and bam, it would be there. What we want to do is we're going to sketch this by hand using the factored form of the equation. Okay, Desmos would be an amazing place to check your answer here because you can check it in lickety-split, no time flat. Okay, let's see if we can factor this thing. So step 1 is factoring, and you can already see that the person who made this question up has factored out the greatest common factor of -3, right? It's hanging out in front of a trinomial. We can also see from looking at this that this is a simple trinomial. Why? Hopefully our review comes and triggers back in. You can get out your factoring booklet here. It's simple because there's a 1 in front of the x squared. Okay, if you don't have it handy, grab your factoring flip book so you have something to look at if it doesn't come right back to you. Okay, so what we're going to do is we're going to draw the x here. We need two numbers that multiply to -8 and add to -2. Okay, I'm not sure why that comes up all the time. So two numbers multiplying to -8. 4 and a 2 work. It needs to multiply to -8. So one of them has to be negative. It needs to add to -2. So I believe a -4 and a +2 would work in that case. Okay, so because this is a simple trinomial, the 3 stays there, we can simply write in those two numbers we found. So x minus 4 is the first factor, and x plus 2 is the second factor. Okay, so there it is, factored. Put a box around that. Excellent. So step 2 is to look at those factors now and find all the details we need in order to draw this graph. Okay, so there's a few things we can see right off. The x-intercepts, if we flip back to that first page, we're looking here at this factored form. So we've got an a. In our case over here, the a would be -3. And we've got two factors, and we can see the r and the s are the x-intercepts. So, grab my pen here. The x-intercepts are x equals, now, consider the negative, so would be 4 and -2. Basically what we're doing is switching the signs that we see. Concavity, that refers to the a. Okay, here's the a, it's a -3, so we know it's opening down. The y-intercept, remember the y-intercept now happens at a times r times s. So we've got a y-intercept at -3 times 4 times -2, which would be 6, and which equals 24. That happens at y equals 24. The axis of symmetry is going to happen in the very center of these two x-intercepts. So if we add these up, 4 plus a -2 is 2, and we divide by 2, we get a 1. Let me write that down. R plus S divided by 2 equals 1. So it happens at x equals 1. And the vertex then, that's going to happen in the along the axis of symmetry, right? So we know the vertex is going to have an x-coordinate of 1. We're just not sure of the y-coordinate. So what we're going to do is we're going to put a 1 in for x and see what we get for the y. What I should have had is in this equation is this equals y, or f of x. That's what it started with. Okay, so now we have that put in. What are we going to get here when we work this all out? We're going to get -3 multiplied by -3, which is +9, multiplied by 3, which is +27. So, if we put that back in here, the vertex is going to happen at 1, comma, positive 27, so very high. Okay, let's see if we can graph this now. Okay, so we've got our x-axis and our y-axis, and I took the liberty of counting by 2s to plot that, so I wouldn't have to do it while we're graphing, or while we're, graphing. Okay, so the y-intercepts, let's put those in first. They happen at 4, 1, 2, 3, 4, and at negative 2. Okay, that's that piece of information. Now it's concave down. We can't draw that yet, but we know it has to open down. The y-intercept happens at y equals 24. That's right there. So we're getting kind of a picture. And the axis of symmetry is going to happen at 1. Does that make sense? It looks like it's in the very middle. This, you don't necessarily draw. You're going to have to draw it in, but I'm going to do it now just so we can see it. The vertex happens at 1, right, on the axis of symmetry. That's good. And at y equals 27, that point there. So now let's grab a pen here, and we're going to try to do a nice, smooth arc for this parabola. And it definitely, when I join the points, opens down. That's quite like it. You can see here when I check it on Desmos that it looks exactly like our drawing. Well done. This next one is an example of when the equation cannot be factored. Okay, we talked about this in class. When it turns out to be prime, we're going to use what's called partial factoring. And I'm going to show you the strategies here. So step 1, we write it down. We figure and figure, but it can't be factored. So when we can't factor it, we use what's called partial factoring. I do not think we're going to have time on this video yet because this program has a maximum of 15 minutes. So why don't you stop it, and we will continue this on the next video.